Hello, everyone. Is everybody caffeinated? Yeah? Filled up of coffee? This room is like, I see a coffee. Okay, leave it. So, okay, two coffees got a joke. So, I'm Irfan. Thanks for the introduction. I'm not like a stand-up comedian, professional stand-up comedian. I'm more like a standby professional comedian. So, because the comedy clubs, they don't accept me much. This is my Twitter handle, no time waste. This is to remind me that I should not waste too much time on Twitter. I work as the lead QA at Upgrad. It's a startup company in Mumbai. It's basically a Udacity. It's like Udacity in India. And we have professional courses for people who are already working. So you can just stop by if you want to check. Okay, so let me ask a question. How many of you have used some containerization tool like Docker or LXC or anything? Like, okay, a lot of people like. Please keep your hands up if you use it for testing also. Please keep your hands up, those who use containers for everything that they do. So there are 4 people, and so these are the 4 people who think inside container. So everything they're thinking inside container all the time, whatever they do. And this is the talk about. This is more about the journey. This talk is like a little bit of technical, but it's a story of a journey that we should embrace. A story about one particular idea that will help you to make your tests more scalable and reliable. So we look at why we need it, what exactly it is. Is it really, does it work, or I'm just lying? And okay, so if it works, how can I do it? And if I know what I do, how can I do it? So what next should be the steps? So before you come to this talk, you must be thinking, why one more talk? Like, why? So few months before, Linux had got 25th birthday. You might have seen this tweet. So somebody wished Linux, this is your birthday cake, go compile yourself. And this is actual cake looks like. So imagine it's your birthday and I give you a cake which looks like this, butter and milk. How you will feel? Like you will get mad at me, like this guy is so mean. Yeah, right? But the sad reality is that we do this all the time. Like we have a problem, we have a solution, we write code, and we say like, take this code, and it might work, but sometimes it works, sometimes it doesn't work. And giving someone just code is like giving a cake with just raw materials and giving a cake like this, which you cannot actually consume. But doing containers for everything that you do is actually the cake that people can use it. So the whole talk is based on this one single idea. The idea is ship all your tests as containers and not code. So, okay, we know what is the right thing, but we don't do the right things always. This is not my picture, but this was probably me sometime back. So, have you heard of a thing called as with great power comes great baggage? Okay, because I just made this up a few minutes before. So I was working in a startup company. I was maintaining the CI/CD process. This was one CI, and we had like a lot of developers. Some were writing Node, some were doing JS, some were Java, Python, PHP, Ruby, and I was maintaining the CI. And this was my condition. Like I was feeling so much pain with so many technologies and maintaining everything that I feel, okay, I have the power, but I have so much baggage. I mean, with every new developer joining and new technology coming, the baggage was increasing. And We should care this because when I see people with lot of power, like people like, okay, these people, how they manage the baggage. They must have something cool to manage their baggage. So they use something called as containers or must something like which the package. So the power lies in packaging, and this is why should we care about this. So, okay, so what was the challenge that you faced while you're testing, or why your test fails? Any reasons? Can you show like any major reasons? Why does your testing gets limited? Environmental, yes.
Test data.
Test data, yes. Anything else?
Dynamic wickedness.
Okay. Sorry?
Sometimes there's actually a bug.
Oh, okay. Okay. So, okay, we'll see some data.
Outdated files are version.
So 45% of the people, they said it's because of unreliable test infrastructure. So what does it mean is you have tests, but they need something to be tested upon, and that is not reliable. Like setting up the test environment, it doesn't work. Setting up your tests, it doesn't work every time. Maybe like it works on some machine, it doesn't work on other machine, and it's a really big problem. And this is actual data. And other people are like unreliable tests. So these are the test failures because of maybe bad code or your tests are flaky. So, and 18% of failures are because of ineffective tests. These are all my analysis, right? So like this can be wrong also. So ineffective tests are like tests which we're just like the tests are there, but they don't catch any bugs, so they are ineffective. And sometimes we feel we don't need them, so we fail to test, but that's not possible every time. So it makes me think that having unreliable testing infrastructure is one of the major things that we should look upon, and we need to have solution for this. So container is not something which is very, very new. It was something which came into picture maybe 100, 200 years before in shipping industry. So they had a problem like they had to ship a lot of stuff like in different size and shapes, and they had to ship these things with the means of different mediums like trains and trucks, and they need a common mechanism to do that, because if we shift our piano and car and have like all these things separately, we need specialist people for managing that. We have the same problem in software also. We have different components. We have databases. We have message queues. We have static websites, front end. This is just a small, like Jason will come up with something like an IoT device, robots. And we have to ship those in development VM, in local, in our production servers, everywhere. If we keep different packaging solutions for everything, we need special people with special skills to manage that. But that's very expensive, and we don't have that much time. So here the containers, they come to rescue. They all look alike same. They are packaged in a unique, so we don't need special skills for managing everything or shipping everything. We can just make everyone developing these components to agree upon some packaging format, and they all exchange their outputs in that format. And it is everything like deploying those changes on these different platforms. So enough talking, like we're talking from morning, what is container? So the container is basically your code, application code, plus all the dependencies, plus whatever you require to make it work in a one single package. So that is a container. It's portable and it's completely isolable runtime environment. It's like Java without JRE. kind of stuff, like, and some entertainment. So it makes me think, like, if you have not actually worked with containers, so how does it affect your? So imagine you have a code and you have configuration, a set of configurations, because configurations always comes in sets. You have one simple program, and then you say, okay, you want to compile it in Linux, or you compile it in Windows, you have to follow these steps. And sometimes the configuration is a little more complicated than the code. And so before container, the life is like you use solutions like Vagrant or Jenkins and Chef. So Vagrant you use for shipping on development. For tests, you use Jenkins or other CI. If you're not using Vagrant, you must be using some VM or some local machines. For live environments, you must be using some provisioning tools like Chef or Puppet or Ansible. If you start using container, everywhere you just have container, and that's it. You don't have a Vagrant or Jenkins or different things. One thing important is that container is not replacement for these tools. They can still work with these tools. The only thing is that everywhere we use the same packaging format. And we are not building or deploying things in a different manner on different environments or setups, like whether it is a development code or testing code. So the important thing is that containers become a unit of exchange between people. So it's like 5 people using 5 languages, but they are actually using a same unit of exchange, which help us collaborating. So containers can be created with different technology platforms. One of the most famous is Docker. Docker is a platform to build, ship, and run distributed applications in form of container. So what it consists of is basically 3 components. The client that you install it comes with the Docker engine, which is a Docker host, and its registry, which is hosting of your images. So here you have containers and images. So containers are the processes that runs on your machine, and images are the static form of the containers. You can take an analogy of a program on a disk with a process. So when it gets into memory, it becomes a container. And a client is something, a REST API. So you interact with the engine with the help of a client. The client, you write Docker and then commands, pull the image or run it, all these things. Okay, so this is what the Docker Hub looks like. Docker Hub is basically a registry. It's like a GitHub for Docker, and we can host, we can share our images on Docker Hub. The good thing is that, okay, by the way, you must be thinking like it's like 5 minutes already, 10 minutes already, and I've not taken name of Selenium in Selenium conference. So it's like, so the good thing is that Selenium is already having a Docker official image, which can be used for running and spinning up Selenium grid, which we can actually look at. So one thing that we should note is containers, they are not VMs. They just, if you look at the difference, they don't have the hypervisor layer. They just have a small container engine. So to run anything that comes with container is you just need a container engine, or you just need the Docker to be installed, and that's it. So we'll take a basic workflow, like what are the basic features that you can work with Docker. So imagine you have a Docker file. We'll mention about this, like what it is. You build a container from a Docker file, and you push it to the repository, and then you can actually clone your container on somebody else's machines. If you just look at it, like these are the commands like build, push, pull, and run. These are the commands which are mostly useful. So how it gets installed, like once you run a Docker run command, it looks for the images on your machine. If they're present, then it can directly spawn the container. If they are not, they look for those images on registry. If it's available, it downloads and installs it, and the container is running. So, okay, that was it. But you really want to see some demo? So I have one recorded demo. It shows as APM running inside the container. So what we have is I have a Docker image for APM on Docker Hub. It's shared on Docker Hub. I'm running it with the Docker run and giving those, and I'm actually sharing my disks directory with the VMs, with the containers directory, and I'm giving the name as test stack. So when you run this container, it has two processes. One is for Ruby, and that's it. So I'm going to start the APM server inside the container. So whatever command I write after exec container name is the command it runs inside the container. So I'm just starting the APM process, and you can see that on the output, APM server gets started. Now if I check back the process, I'll see one more process is added inside the container for APM. And so now I can start the test. So this is the test which actually connects. I'm running from a Linux server to connected device, and it is getting screencasted and recorded here. So all these interactions are being logged on to the APM server, which is running inside the container, and the test is running in the other node. So it takes a little bit of time, so that's why I'm not doing it live. And by the way, it's not recommended to start APM server explicitly, but we're just doing it to check whether the process was actually running fine inside the container. And all these code examples and everything, it's shared on GitHub, and the images are on Docker Hub. So you can actually try this later on, whenever you today or tomorrow. We'll start the journey of containerizing everything, and you can just do this at your own time. So we saw the tests running, they are passed. The screencast is still going on. And after that, I will just stop the container. Yes. Okay, so now we know that it really works, it can be used, but now the real question is, how can you use it, and how can you start the journey of containerizing everything? So you want to containerize your stack. What are the steps that you will follow? You install Docker. The good news is that Docker is now completely supported on all the platforms, and you can install it with Docker Toolbox, or Docker for Mac or Windows, or Docker Engine for Linux. By the way, I'm skipping a few things, and we can interact later on, and we can just see the examples on GitHub, and we'll focus more on the demo and the other things. The second thing is that you analyze your testing framework, and you see what are the infrastructure requirements, or what are the things that you want to install to support to your framework, and you write a Docker file for your framework. So Docker file is basically a configuration file with a set of commands that you want to basically go look at your README, which says install this before, and just put them all in your Docker file. That's it. And that will be the first version of your Docker file, and then you can actually refactor it. So this is the example of simple Python application. You're starting you're taking an image, and then you're adding these steps and exposing a port and starting a command. Sorry. So third is that sometimes you need to have multiple containers interacting with each other. So you like having a database and you have like front end and then APIs. They need to have interaction with each other. So in that cases, you need to look at Docker Compose, which is the simplest solution for this, and this will be our using for demo. So Docker Compose consists of a YML file having configuration, and basically you have to give the name of the image from the registry. If it's already there, it's very good. If it's not there, you have to write the whole command, and you have to give configurations like what are the volumes, what are the links, what ports you are exposing with respect to the localhost. So we have let's take an example. You join a new company and they have a product called as a simple voting app. It has got a front end which you see like this, like choose anything from bug or feature. So, and it gets reported to a dashboard which shows how many people reported it as bug and how many as a feature. So it's the structure is like there is a backend, a voting app, APIs, there is a Redis queue, there is a worker, there is database, and there is a front end. So simple SOA-based application. So what you have to do is you have to containerize the test. You have to write tests, automate it, and containerize it, and give it to me so that I can run it, or you can run it. Anybody can run it. And so API test and web test with Selenium Grid. So the solution is you use Docker Compose. In this example, you have all those containers. You containerize all those components and keep them as a separate process. And then you Dockerize your stack, and then you use the existing image from Selenium Hub and existing image from APM and Chrome, and you can have multiple Chrome and Firefox nodes attached to this Selenium Hub. So, okay, let's see if it really works. So, we have a compose file. Okay, so let's run it first. So we have a compose file here. So to run it, basically, so this is the repository that you have. If you want to do setup without Docker, you have like 1 hour of work. If you want to do with Docker, you have just some 10 minutes, and you can just write these commands and running. So I'm just using these commands to set it up. It starts all the containers, and you see the Redis queue, voting app, front end, everything, and the grid. Everything is okay. Okay, yeah. So they are listening up. So your grid must be running at. Okay, so you have one node attached. If it's very easy to scale it up, you just write compose, and then you give the component name it's equal to, and it gets scaled up to multiple WebDriver sessions. Okay, and you can run one test. Let's see. So this will, okay. Sorry about that. So this will run the tests inside the container, and you can see the output here. It just got finished, I think. We can run one more time. These are the two tests. There's a very simple test basically with Cucumber, and so it gets finished inside the container. We have some API tests also. You can run. You can actually play with this on GitHub repository, and you can see this. So you see this in the first window. These are actually hitting the containers So you can see that, okay, so these are actually running inside the container. So all these tests are container-to-container interaction. So that was a demo. So what next? So the next thing is containerize everything. And to start the journey where everybody is talking the same language, irrespective of what actual language you're using or what stack you're using, or you're using Java or Ruby, or you are a web developer or anything, just talk in terms of containers and give actual cake to eat people. A simple CI workflow that you can, I don't think we have time for the demo, but you can run it on the same repository it is hosted. So how CI workflow changes if you have Docker. So apart from your code, every change in code will also build your images and not just your code. So and all your tests and everything will work on those containers itself. So Docker has automatic builds. They have a different setup for automatic builds. So every time you do a change in your repository, a new image gets built, except updated. By the way, the images are also layered, like the GitHub code. They added up like layers and layers. And if the test is successful, so new image get pushed to the Docker Hub repository. So that's it. We have 5 minutes time for the Q&A. Any questions? Okay. Yeah.
Hi.
Hello.
Do you build your Docker images with every commit? And if so, what do you do to avoid the overhead in rebuilding your images?
Okay. So I'll repeat the question. So the question was that with every commit, should I rebuild my image, and how do you avoid that? So it's not necessary to rebuild your entire image every time, but only if there's a change in your setup process. So mostly what happens is you keep adding the tests, but your setup process remains the same. With every test, you don't install a new Java version or something else. So there is hardly a change infrastructure side of it. So in that cases, we don't need to do it on that frequent basis. So code changes are always way ahead than the infrastructure changes for the supporting code. So that thing is not a major issue. But since we have the Docker automatic builds, so you can choose for building your images from Docker Hub. It takes some little bit of time, but you don't have to manage that infrastructure yourself. So that is what we do actually. Does that solve your problem? Okay. 3 minutes left more.
Probably a silly question, but you know how you were showing a visual session of the browser running Chrome?
Yeah. Yes.
Where does that run?
So yeah, it's a nice question. So basically, the Docker containers that I'll just open this up. So sorry. So the official repository of Selenium, the Docker Hub image that we have, has a VNC installed in it, XVFB. So we just need to have a VNC link to it, and it runs on a port. So in our configuration for compose, we can specify the port. By the way, we are using Selenium 2. There is a separate branch for 3 also. We specify the port. So whatever UI that is actually running on that particular Selenium test, it gets mapped to the port on your local, and we can connect our VNC to that port, and we can see the visual things happening at that time for live debugging. So that is how it works.
And do you know if it works for Windows as well?
Yes. So this is what we are using is something called as VNC, it's a free software. Yeah, it's called as Real VNC. It's a free software. You can use it and it works everywhere. Yeah. Any more questions? We have like 1 minute more.
Hello. My question is, I saw the demo on Appium, so I would like to ask if you are using also the Docker and Appium for iOS application, if you have some experiences with this.
Okay. So, so in our company, we don't have the iOS app for now, so I'm not doing that. But for Android, we am doing it at. So what we have is we have some Docker scripts for APM. There are some base images, and so what we are doing is we are just like how you install APM on a Linux server or anything. You just need to write those steps here, and you basically I have this image of Docker Hub. Okay, so I'll just in the main Docker file for my repository, I'm just using one of my own images, and so this actually has the configuration for installation, and then when I'm running it to connect to the real devices, I'm sharing my USB ports and device configuration with the container running on it. So when you are running a container, you can specify some privileges and share some files and port it to the files inside the container so that you can actually connect to those USB devices. Does that solve your question, answer your question? Okay. Okay, weird. This time.
All right, thank you, Irfan.